Hello everyone, thank you for joining. I'm Jamal Arif and I'm part of the Oracle Cloud Infrastructure team. Today we are going to talk about Edge services. This is a level 100 course, and in this course we are going to talk about the Edge services on Oracle Cloud Infrastructure. So this is our safe harbor statement. I'll give 1 minute just to let you read through the statement itself. So what are the objectives of this course? So within this module, we are going to cover three core areas within our edge services. We're going to talk about the DNS Zone Management. We also are going to take a look at what are the different traffic management tools available within the DNS within the edge services. And we'll take a look at all the different traffic management policies that you can create. And at the end, we'll see the OCI health checks and how you can integrate the health checks with the traffic management. All right, so before we talk about the actual OCI service, let's take a step back and take a look at how DNS actually works. So at the simplest level, all the DNS system does is convert a DNS name into an IP address. However, as you would expect, that there is a large degree of complexity behind the system as well. Every domain that is registered creates a DNS record, usually hosted by a company that registers the domain. However, once registered, the domain name can be transferred to be hosted elsewhere. This is simply a text record that stored details about what information should be given to anyone requesting details about this domain name. So in reality, there are variations and optimizations of the system to improve the reliability and efficiency. But essentially, let's go over the process of how, when you write anything in your web browser, how the DNS system works in the background. So for instance, you type something like oracle.com in your browser. A check is made to see if the details of that name are known locally within your own OS operating system that you're running. So for instance, if you're running a Windows machine, like your host.txt file, or if you're running a Linux machine, you're either the resolve conf file or your host file. If no local record is found, a request is sent to your local DNS server. This could be running locally on your machine or in an office network, but most commonly it is provided by the ISP that supplies your internet connection. This is sometimes called as the recursive DNS servers. So the local recursive DNS server again checks that if it already has the details of the name being requested. If there is no cached record, then the DNS server needs to locate the details of the name server that hosts the domain record for the address you are trying to resolve. That is the authoritative domain name server. So to do this, the DNS server breaks the name down into different sections, starting from the right-hand side of the domain name. So for instance, you have written www.oracle.com. This would be split into .com, Oracle, and www. The section after the final dot of the domain name, that is .com, is known as the top level domain. A root name server is first connected to find the details of the server that holds the domain record for the top level domain. The DNS server will make a request to the top level domain name servers, asking for the details of the name servers that contain the details of the next section of the domain name. In this section, for instance, Oracle. So the domain name server then makes a request to the name server that holds the details of oracle.com. This name server may then return details of another name server that holds the records for www.oracle.com, or more likely at this point it will probably return an address associated with www.oracle.com. The address returned by the remote name server can be an IP address, or it could be another domain name known as a CNAME as well. For example, it may reference to another CNAME for www.oracle.com. If CNAME is returned, the DNS server then repeats the process with the CNAME until an IP address is resolved. So moving forward, let's talk about uh, DNS Zone Management. So the Oracle Cloud Infrastructure Domain Name System service lets you create and manage your DNS zones. You can create zones, add records to zone, and allow the OCI Edge network to handle your domain's DNS queries. So now I'm logged in into my OCI console. On the home page, I can navigate to menu, and within solution, platform, and edge, I have edge services, and then to DNS zone management. Recently, we launched newer services which were DNS zone management plus traffic management trading policies, the health checks, and WAF. So let's head down to DNS zone management. Right now, when I'm in the DNS zone management, you can see that the scope of the service is defined. So you have, I'm currently in the Ashburn region, and the scope is defined into a particular compartment in my tenancy. So from here, I can create zones. So if I have I've already registered this zone with the registrar. I can create a zone over here and then delegate that zone onto my registrar. So let's go ahead and try to create a zone over here. So once you create a zone, it gives you a couple of methods. Either it can be a manual creation of a zone, or you can import a zone file as well. Within the zone type, it tells you that whether you can select a primary zone where the primary DNS refers to the DNS provider with control zone file modification. You can also select a secondary zone. If you select a secondary zone type, it would then ask you for an IP of your master or server as well. So over here, I'm actually creating a primary zone because I'm keeping OCI DNS as my primary DNS service, DNS server, and I can then provide the zone name which I own. So for instance, if I own example.com, I can just provide the zone name over here. So just for test purposes, I've already created a zone that I own. So OCI-demozone.net is one of the zones that I own, and I have already registered it with a registrar. If I click on OCI-demozone.net, I can see that the zone has been created, and this is a primary the zone type within OCI DNS service, and I can also see the details of the name servers. Within the records, I can see there is a SOA record and then different name server records. I can also see a single A record which has been added by myself. If I click on add record, this is where I can add additional records. So I can add a record, just like we mentioned in the slides, there are a bunch of different record types that are supported by the DNS service. So you can see that there are multiple different record types. Detailed of this is available in our documentation. And if you want to add, for instance, an A record, it would ask you the label which you want to add to your zone that you have created, the TTL, the time to live for this A record, and then the IP address for the record. So just like here, I have created an A record as well. So web.oci-demozone.net is my ACK record. A record, I have added a 30 TTL, and it's an A type of record, and the IP address that I've assigned is the public IP of one of the instances within OCI. So let's go ahead and add a record to my zone that I've just created. I have a compute instance running on Oracle Cloud Infrastructure. This is the public IP address, and I would create an A record against the public IP address of this compute instance. So I will click on add record. This is an A record address that I'm creating. I can give an example of, for instance, create a label of demo.oci-demozone.net. That its IP address is, so I will just copy the IP address from here, paste it in the IP address on this side, and then just unlock the TTL time. By default, these are the 30 seconds, but I can just do again a 30-second TTL for my record and submit. Once I submit the changes, it creates the A record that I have provided, but it doesn't publish the change on the DNS servers. So we before we it activates, we need to actually publish these changes with the changes that we have created now. So I'll go ahead and create to publish changes. It would again show me the domain, the A record that is going to be published now based upon the TTL and the other R data value that I'm providing. So I'll click on publish changes. It will take a minute to just verify. And now I can take a look at my details page and see that a new A record has been published with the label demo, and the zone name is the same zone name that I had. Now let's open up another tab and go to the demo label that we just created. So if I go to demo.oci-demozone.net, it navigates to the compute instance, which is running a basic web server and basic HTTP web server, and it navigates to that compute instance. So it shows me that it's a web server 2, which is running on Oracle Cloud Infrastructure, and this is just a basic index page on that instance. All right, so moving forward, let's talk about traffic management on OCI DNS Edge services. So the Oracle Cloud Infrastructure Edge Services has advanced traffic management capabilities to steer your DNS traffic across multiple public OCI endpoints or other third-party endpoints as well. The traffic management supports comprehensive policies to provide intelligent responses to ensure high performance, scalability, and availability. You can also link the health checks along with the traffic management for different use cases. And as we go through the different options of traffic management, we'll see that how we can attach an OCI health check with the traffic management policies as well. So let's take a look at some of the common use cases which we commonly see within the traffic management. The first one is a failover, where where you have either a DR site or you have some DR site in a different region, and you are forwarding or directing all of your client traffic to a particular region, which is your primary site. If for some reason the primary site fails, you can set up a failover scenario or a failover traffic management policy within your DNS to forward the traffic to your DR site, which is your secondary site, in case of a failure. The failover, when you set up the failover, you can associate different health checks, and based upon the TTL values that you have, it would fail over to your secondary site. Additionally, cloud migration is another common use case where you use the load balancing functionality within the traffic management policies, in which you have the ability to load balance your traffic based upon the weight that you provide to your individual endpoints. So for instance, if you're migrating your application to cloud and you still want to have 90% of your data being sent to your on-premise primary site, and just to test out the things, you just want to send out 10% of your client requests to your data, which is sitting inside the public cloud, inside a cloud. So you can do so using the load balancing traffic management policy within the DNS service. Very similarly, this can be another use case where your application is sitting across multiple regions for load balancing, and you want to make sure that most of your clients are being helped with 60% within one of the regions, and then the next are 25% in one and 15% in the region 2. So you can leverage the load balancing traffic management policy along with the DNS service. Just like the failover scenario, you can also link the health checks with the load balancing traffic management steering policy, and in that case, if one of the region or if one of the sites goes down, you always have the ability to fail over it to the other two sites which are active and serving traffic. Very commonly, we also see that there are, in certain cases, as applications are moving towards the cloud, you have hybrid or multi-cloud environments, and you want to segregate your traffic based upon the IP group individual of your clients. So you can definitely do so using the traffic management steering policies as well. Very commonly, you see that there are use cases where you want to have some traffic which is like based upon your geographical region. For instance, you have application is a e-commerce site, and for your European customers, you want all of your European customers to go to your European sites because of it's a different language. For instance, if it's a different language that they are using, and all of your North American customers want to go to a different site because of a different application running on it. So using the geolocation steering, you can make sure that users which are coming from a specific region are directed to workloads which are in a specific region as well. And you can always again combine your health checks for failover. If one of your region fails, they can fail over to the other region. Then a couple of more examples where you can do use the IP prefix for canary trusting, or use an ASN number for steering your traffic to a particular workload within the cloud. So let's go and take a look at the different traffic management policies available within OCI. So you have a load balancer traffic management steering policy. You have failover, geolocation steering, and then ASN steering and IPv6 steering. So instead of going into one by one, what I'll do is that I'll just log into the OCI console, and we'll create or take a look at how do you create each one of these policies, and what are some of the options that you have to use when you set up the policy, and how do you connect or attach a health check with the traffic management steering policies as well. So for demo purposes, here is my lab environment for the demos. So I'll have a couple of web servers which are running in the Ashburn region, and I'll use different traffic management steering policies to steer the traffic based upon the policy that I set up. And I will just try to, so the zone name that I am using is the OCI-demozone.com, and I'll create different labels along with these zone name. And once I create the traffic management sharing policy, I can have a policy, for instance, a failover profit policy where my primary is a web server 1, and my secondary is web server 2. So when both the servers are running, it would whenever I want to go to that particular zone, I would always be forwarded to the web server 1, and then I'll do a failover where my web server comes down. I'll see that how it actually fails over to the web server 2. So I'm logged into my OCI console. From here, I can navigate to the traffic management. So let's go to Add Services and then to Traffic Management Steering Policies. Let me actually show you a couple of my web servers which are running in the Ashburn region. So I have a web server 1 and a web server 2. And the details of web server 1 are inside the details page, so I can see the public IP address, the private IP address for each web server. And similarly, if I go back, I can go to the web server 2 and take a look at the IP address information of web server 2 as well, the public IP information. So I'll just open up the instances in each of the tabs so that I know the public IP addresses that I'm going to use in the A records that I'm going to create. And let's go back to the traffic management. So once you are at the traffic management steering policy, click on create the traffic management, and it gives you the 5 options of what kind of policy type that you want to create. So these are the 5 policies that we went over during in our slides as well. So you have load balancer, failover, geolocation steering, and then ASN and IP prefix steering. Let's start with failover steering. In failover, just provide a generic name for your policy. So let's just say demo The TTL I'm going to give is 30 seconds. So 30 seconds is the failover time that it's going to take. Over here, I'm defining an answer pool. So for failover priority base, it's always 1. And I'm create a pool for my for my web servers. So my answer pool is, for example, the first answer pool name is web server 1, and I can just name the answer pool as web server 1. I have to create an A record for my web server, and in the answer pool 1, which is web server 1, I can give the IP address of my instance in let me just go back to the Ashburn region. And within the Ashburn region, I can go to DNS demo 1, which is my first web server, and I can just take the public IP address from here and paste it in the page over here. I will create another pool, which is my web server 2, and create another record for this one, copy the IP address of my second web server and paste it over here. So I've created 2 different answer pools. Now here I'm going to select the pool priority. So I'm setting up pool 1 as my primary, and I'm setting as pool 2 as my secondary. So if both of the pools are away up, since this is a failover policy, it would always send the traffic to pool 1. Now I can also associate a health check. In the health check, I can provide a name, so I can say health check for my failover policy. Provide the interval in seconds, choose the protocol between HTTP or HTTPS, and then some advanced options that what kind of port. So I have it should be on port 80. I'm just providing a basic path, which is my index page, and then I'm just using the option, not using the optional parameters over here. On the domain, I'm going to attach a label of failover to the zone that I have. So failover.oci-demozone.net. Now I can go ahead and create the policy. The policy gets created in a minute, and then you can see the details page of the policy. In the details page on the top, it just gives you information that what type of policy it is, what's the TTL, and then how many answer count. It also associates that mentions that what is the attached health check with this policy. In the policy narrative, it tells you that what's the policy priority that you selected when you were creating multiple pools, and what is the priority that you selected. So you can see that you have the answer pool priority, where web server 1 has greater priority than the web server 2 pool. And in the policy answer data, you can see the health status of each individual servers or A records that were provided over here. This actually, the answer data over here that is provided is available through the health check. So the health check says that the status of the health check is healthy, and it is based upon the TTL value that you selected when you create the policy. So if any of the if web server goes down, the traffic should be failed over to the web server 2. If web server is 1, then the traffic would always be forwarded to the first web server. You can also, on the left hand side in the resources, you can also take a look at the attached domains. So right now the attached domain is the failover.oci-demozone.net domain that we created. And if there are any unpublished changes that you have made and you have not published them, it would show up in here in the unpublished changes. I've opened up an incognito window, and let's go ahead and go to our zone that is attached to our failover policy. So that is failover.oci-demozone.net. And you can see that this actually reflects to the first this actually resolves to the web server 1 in the Oracle Cloud Infrastructure, a demo page. So if I just do a refresh, every time that I'm doing a refresh, it's always going to the first web server because my web server is up and running, and the priority states that it should always be resolved to the first web server. I will navigate back to my OCI console. So this was my web server 1, which is currently serving all the traffic. How about if I stop this web server and just trying to mimic a failure on the web server one, and I'll see that how my failover policy on the traffic management would divert the traffic and now resolve to my web server 2, which is serving my traffic. The instance has stopped now. If I navigate back to my policy, the traffic management policy, I can see that the current health status still shows healthy because of the TTL that is set on my failover policy. However, if I go back to my health checks, I can get more detailed information that how my currently my web servers are behaving. So the health check that I created was health check failover policy. I'll go into the health check failover policy. This is the health check that was attached to my failover policy statement. And in the health check history, I should see that through the different vantage points, what is the current status of my web server. So you can see if I scroll down, uh, like maybe a minute ago when I haven't had not made the change, I could see that all of the both my web servers, you can see the different endpoints. Both my endpoints were active, and the different from different vantage points, the health check was coming as available. But now you can see that in the latest, since the health check that I created was updated, I think after every 30 seconds. I'm seeing that after each 30-second time frame, you can say the timestamp over here. There is a difference from different vantage points that one of my web servers, which was my web server 1, is currently down. So let's go back to the traffic management and see that if the health status is changed in the traffic management policy as well. Since the traffic management policy picks up all the data from the health check, it should reflect back over here as well in the health status that one of the instances is unhealthy. So now let's open up another tab and go to the endpoint again. So if I go to failover OCI-demozone.net, I can see that now the traffic is being served from the web server 2, and the traffic is automatically diverted and resolved to a different backend endpoint which is currently active. All right, so moving forward, let's go ahead and take a look at the other traffic management steering policies. So we have load balancer. If we select load balancer, there are a couple of changes that we have in the way that you set up a policy. So you define a policy TTL. In the same manner, you can have more than one answer counts, and you can add additional answers. Against each answer, basically, and against each record that you create, you can assign a weight to it. And based upon the weight, you'll like the answers value increases. The higher the value, the more likely it is to be served using the load balancer policy. So for instance, if you want to do 90 and 10%, in that case, the first answer is going to be hit just 10% of the time, and the next is going to be the hit 90% of the time. Just like the failover policy, you can also associate an health check and attach it with the policy. So right now it's giving me an option of either selecting a health check which is already created in the previous policy, or I can also go ahead and create a new one, or I can just not associate a health check and regard like whether they are healthy or not. The only policy that the DNS traffic management would take into effect would be the load balancing, and it would not matter that whether whether that backend is healthy or not. And then similarly, you can attach a domain as well. If we go to additional like geolocation steering, and the geolocation steering example, the differences are that you create multiple pools, and then within each pool, you can associate a particular location with it. So for instance, I can associate different either continents or based upon different countries and regions, and then associate that to an individual pool priority. I can also do a global catch-all. So for instance, users in Japan should go to my end point, which is in JPAC area or users which are in European region should go to my endpoint which is in European area, and users from North America should go to the endpoint which is in North America. But all the other regions, for instance, somebody connects from Australia, I can have a add global catch-all, which means that all of my other regions which I don't have a specific priority for, I can always send them to my like default back endpoint, which can be either in any of the answer pools that I have created. If I don't define a global catch-all, then it would just randomly select an answer from the available answers that you have. Similarly, like the other policies, you can also attach a health check over here. So it also gives you an option of either associating as available health check or creating a new one. And then you can attach the domain, which is also optional. The other two policies are very similar as well. So if you select the ASN steering policy, the ASN steering example gives you the differences would be that in this case, when you are defining the rules, you define an ASN number for your organization or for a particular organization or a telco that you want the traffic to be routed to. And similarly, you can also add a global catch-all. In case of IP prefix steering, when you are setting the rules, you have to define individual IP subnets. So you can add like something like this and then create a subnet which create a rule based upon the subnet address that you want to route the traffic to. Again, you can also add an additional add global catch-all over here as well. So let's go ahead and do a quick demo of a geolocation steering. So I'll just go ahead and quickly create one of the geolocation policy. I'll give it the 30-second TTL. In the answer pool, I'll create again the same web server 1. I'll create another a name and forward the traffic to my web server, which is this is the 2 web server, and I have another. This is my first web server. Oh. And then my server pool 2. And then attach the public IP address of my DNS demo 2. Over here in the geolocation, I'll provide the areas from where I want to connect to. So let's say I have a North American region, and in the North America I want to connect to pool 1, and as a secondary I want to connect to pool 2. However, from Europe I want to connect to my second web server, and as a backup would be my web server 1. I also want to add a global catch-all, and for global catch-all I always want them to go to my web server 1, and then as a backup go to my web server 2. I can attach a health check policy. So I have a health check policy which I created in the last failover policy. I can just use the same health check over here and then add a domain name saying geo example and select the same zone that I have. Click on create policy. So I just selected the policy over here. Once it gets created, you can take a look at the policy, the geolocation policy that is created. So you have a details page which lists similar information, provides you the health check which is attached with this, and the TTL associated with the current policy. It also gives you a policy narrative. So in the policy narrative, you can see that your North American servers clients would go to the web server 1. Your Europe clients would first go to web server 2, and then for a catch-all, they will always be forwarded to web server 1. In the health check, you can take a look at the health check of the 2 web servers that you have, and currently both of them are healthy. So let's navigate to the zone that we have attached. So in this case, we have attached geoexample.oci-demozone.net. So I'll just go ahead and write geoexample dash. So you can see that it navigates now to a web server 1 in my backends, because currently I'm based out of North America, and it's always forwarding my traffic based upon the geolocation steering that I'm doing to the web server 1. I also have like a basic Linux box running in Frankfurt region. So currently I have this Linux box which is in EU Frankfurt 1. So I'll just try to log in into this Linux box and try to see if. So I'm logged into the Linux box in Frankfurt, and I will use a browser inside my terminal and try to get to the endpoint, the same endpoint. So geoexample.oci-demozone.net. This time it should resolve to web server 2 because my policy states that anybody in geolocation as Europe should connect to the backend server as web server 2 as primary, and then web server 1 as secondary. All right, so the last thing that we are going to cover in this module is the health checks. So within the like menu on the left hand side, you can come down to Edge Services and then you can navigate to health checks. The health checks scope is also defined as in the current demo that I've been doing testing in. So these are the two health checks which were already there. We created one of the health checks, the failover policy check, when we were creating the traffic management steering policy for failover, and we used these failover policy check with the health check with other policies as well. I have created another health check way for a ping level test. So let's go ahead and see that what are the options when you create a health check. So you can define any particular name. So for instance, I can do a demo health check as my name of the health check, the compartment that I'm currently in. Then it gives you to select the target. So it would populate the targets in your current compartment. So there are two web servers which are running in my compartment, but I can always add additional like endpoints as well. So for instance, if I have other endpoints which are either on-premise and I have a public IP with me, so I can just define a particular public IP and just define it as a new target. Then it allows you to select the vantage points. So the vantage points are from where it would test your endpoint. They are distributed across the globe, so you can see that they are either in US and EU or Asia Pacific, and you can select that what is your vantage point for all of these health checks. So I can select like Asia Pacific, I can select one in the east and one on the west side. And then in the request type, you select what type of protocol it is. Is it a HTTP or a ping protocol? If you select ping, it would just populate the protocol for ping, which is the ICMP protocol, and then you can select the interval and the timeout value. So the interval would be the frequency of how often the health check is run, and the timeout is the maximum time to wait for a reply before making the probe unavailable for that endpoint. If I select an HTTP endpoint, it would give me some additional features like whether the protocol is HTTPS or HTTP, the port exactly for this request type, and then the path at which it should do the test. You also have the option of adding additional headers with it. And then in the bottom, you can also add methods, whether you get a head or a get method, and then additional interval and timeout values. You can always attach a namespace, like a tagging namespace with it as well, just like any other service. You can use the tagging namespace over here. So let me go back to one of the like health check policies that I've already created, which is a ping test. So the ping test is currently running for the endpoints that I have in North America region, in Ashburn region, and I have two web servers, and I've had different vantage endpoints within South America, and then one in US West, and then one in Central CA. So you can see that in the health check history, I can give details that what is the current status of my health check for all the different workloads. So on the left hand side, I can see the target. So there are two targets currently. Right now there is no filter that I'm setting up, but I can set up filters for exact start date and end date. And then I can see that after every 30 seconds they are populated based upon the TTL value that I had, based upon the interval actually that I had. One thing to mention over here is that since I'm doing a ping test, I have to specifically allow ICMP ingress and egress traffic on my web servers as well, which is running inside the Oracle Cloud Infrastructure. So the OCI, the web servers are running inside my VCN, so I have to specifically open up the ICMP rules to make them work. This actually completes our module for edge services. Once again, thank you for joining and see you next time.